Section 7.2. For this section, we're going to convert values from a normal distribution to z-scores, find the areas under a normal curve, and find the value from a normal distribution corresponding to a given proportion. So we're pretty much going to do what we did in the last section, only it's going to have word problems now. Recall that the z-score of a data value represents the number of standard deviations that data value is above or below the mean. If x is a value from a normal distribution with a mean and a standard deviation, we can convert x to a z-score by using a method known as standardization. The z-score of x is z equals x minus mu divided by sigma. So this is an important formula right here. You want to write this down. Things to watch out for in this formula are mu is given and standard deviation is usually given, and this is the value they usually give you in the word problem. You have to make sure you have it in the right order, x minus mu. That way you'll end up with the correct number, either positive or negative. For example, a woman whose height is 67 inches from a normal population with a mean equal to 64 inches and standard deviation or sigma equal to 3 inches, the z-score is, so you do x minus mu divided by sigma, and then it's going to be 67 is x right here, 67 minus 64, 64 is the mean, divided by 3, 3 is sigma, so you do 67 minus 64 is 3, so 3 divided by 3 is a 1. So notice these graphs, two graphs that they are using. Notice the two curves that they're showing here, standard normal curve, both of them. One of them, they're having z as the x-axis, so remember the mean for the z was 0, 1 standard deviation away here, 2 standard deviations, 3 standard deviations, -1, -2, -3, and over here we have the mean was 64, that's why that appears right in the middle, and standard deviation was 3. So notice how this, they just didn't, this is just broken off by 2s. It should be broken off by 3s, but they only did it by 2. But 1 standard deviation away falls right on the 1 here, and this is 1 standard deviation away here, which should be 64 plus 3. So that should be 67, and that's exactly where we are, 1 standard deviation away. Table A2 may be used to find the area to the left of a given z-score. We talked about area to the left, and then I had my extra chart there to help us out. And if we look back over here, tables, my shortcuts right here, to the left, you look up the number, that's the answer. If it's shaded to the right, you look up the number, you have to subtract it from 1. In the middle, which is this one right here, in the middle, you look them both up and subtract them from each other, and then the outside edges. So for this particular problem, now we're going to look up an answer. A study reported that the length of pregnancy from conception to birth is approximately normally distributed with the mean of 272 days and a standard deviation of 9 days. What proportion of pregnancies last longer than 280 days? So last longer means greater than, so I'm looking at for greater than 280. So according to my chart, greater than is right here. So I have to look the number up and subtract it from 1. So this is my greater than right there. So x minus mu, so 280. 280 again is the number that I'm looking, or that they give me. Minus 272 is my mean. Divided by 9, do the subtraction, divide by 9, you get 0.89. So you look up 0.89, so here we are, 0.8 all the way over to 0.9, the intersection right here, 0.8133, but since this is a greater than, you have to subtract it from 1, which is right here, so this is your answer. 0.1867. So we conclude that the proportion of pregnancies that last longer than 280 days is 0.1867. The length of pregnancy from conception to birth is approximately normally distributed. So again, they gave us the same numbers. The mean is 272, standard deviation is 9. And now I want to do between 2 days. So between 252 and 298. So when I'm doing an in-between, I calculate both z's, look them both up, and do a subtraction. So that's the subtraction happening right down here. So for the 252 number, 252 minus 272, again, this is mean, this is x, divided by sigma, so that comes out to a negative 2.22. I have to look this up on the chart. And then the z-score of 298, again, 298 minus 272 divided by 9, I get 2.89. So I look these both two numbers up on the chart. When I'm looking up 2.89, I get 0.9981 on the chart, table A2. Then when I look up a negative 2.22, I get 0.0133, and this is an in-between, so I subtract the two z numbers, and after the subtraction, there's my answer, so 0.9849. So the proportion of pregnancies that are full term between 252 days and 298 days is 0.9849. Then they have some calculator use. Again, you can look this up if you're interested in this. PowerPoints are posted in Blackboard. Suppose we want to find the normal value or the value of the normal distribution that has a given z-score. To do this, we solve the standard formula. So what they're doing is, I want to solve this for x. So I multiply both sides by sigma, and then I'm going to add mu. So that's where they get this formula here, x equals mu plus z times sigma. So now I'm going to be able to actually calculate the value. An example of this, heights in a group of men are normally distributed with the mean of 69 and a standard deviation of 3. Find the height whose z-score is 0.6. So now I have to find, or I'm using a z-score of 0.6. So I put that 0.6 right here for z. That's where you see this, 0.6. Sigma is 3, right here, sigma is 3. And 69 is the mean. So when I multiply 0.6 times 3 and add 69, I get 70.8. So we interpret this by saying that a man 70.8 inches tall has a height 0.6 standard deviations above the mean. Some steps for the normal procedure, and you want to find this. First, you can sketch the normal curve, label the mean, so you can see where you're going. If the given area is to the right, subtract it from 1. Again, these are all my little shortcuts. Look in table A2, find the value closest, and then do the calculation. So in the previous example, they gave us z right here, 0.6. Now we're going to actually have to find it. So let's try this. Mensa is an organization whose membership is limited to people whose IQ is in the top 2% of the population. Assume that scores on an IQ test are normally distributed with a mean of 100, standard deviation of 15. What's the minimum score needed to qualify for membership in Mensa? So right now the figure shows that the value x separating the upper 2% from the lower 98%. So these are the upper 2%, this is the lower 98%. So the area 0.02 is on the right. So we subtract that from 1 and we work with 0.98 on the left. The area closest to 0.98 from table A2 is 0.9798. So where they're getting that from is they are looking at this backwards. They're looking up 0.9800 in the middle of the chart. So if we go back to our table and I try to find 0.9800, so again I'm just searching 9800, looks like it's here or here, right? This is 0.9798 and this is 0.9803. The 98 is only 2 away, the 03 is 3 away, so I would choose this one here. and that would correspond to a 2.05 for the z-score, which is what they have right here, 2.05. That's where they're getting that number from. So this is the mean, that's in the problem, 100. 2.05 was the z we looked up. The 15 is sigma. Multiply 2.05 times 15, then add 100, and you get 130.75. So since IQ scores are generally whole numbers, we round this to 131. And then calculator issues here again. If you have a TI-84, you can go through those steps there. Now the next example will be problems.